The double complement law is so simple that I actually used it as the first example of why simplification was used. Notice this funky symbol above the A here? It's just a not symbol on top of another not symbol, so it's a not. The law states that if you have two nots acting on the same value, then that's just the value by itself, as they cancel each other out, just like two negative numbers would. It's even more obvious when you see the circuit diagram and truth table. Let's feed a 0 into the input. You'll see the first NOT gate inverts it to a 1, then that enters the next NOT gate and it inverts it back again to a 0. The same's true with a 1 input. The first gate inverts it to a 0, then the second gate takes that 0 and turns it into a 1. As the input A and the output not A give the same values in the truth table, we might as well just dispense altogether with this double not and just pop in the original value on its own. In action then, we've got this expression, which is A or not B or not B. Now let's chunk that up so that we can see what we're working with. Remember, AND laws will apply to the yellow chunks, then OR laws to the pink chunks. So, firstly, we can see that the not B is there, so we can apply the double complement law and that simply becomes B. Now we've done that though, we can see that we also have a B or not B as part of the expression. Now, we've seen a law that applies to that before, the original complement law, which means that we can simplify B or not B to just a 1. That leaves us with A or 1, but that feels like it probably has a law that applies to it. Let's have a look and you'd be right. The annulment law tells us that anything or 1 can be simplified to just a 1, meaning that that entire expression was just a 1 signal all along. Whoa, now this is a big old expression. A and B or C or A and C and not A. Bit of a mouthful to be honest. Let's chunk up this bad boy. We can see the linked ands and the linked ors to know where we can apply the rules. Well, let's start with the double complement bit, as that's the title of this very video. Boom, that not A is replaced with an A, and suddenly the third expression looks a lot like we can apply the idempotent law to it. It's got two A's linked with ands, so that would mean that we could remove one of those as it's a repeated term. And there we go, a much simpler expression, sort of. I mean, the reality is that this wouldn't be the end. There's more simplification that we can do. So, let's go and have a look at a few more rules that might help us get there. That's it for this video. Don't forget to like, comment and subscribe to get more computer science content.